Welcome to this channel. In this video we are going to be looking at derivatives, and this is part 1, right? So first of all, we need to understand what the derivative is all about. So in simple terms, the derivative simply explains the rate of change of a variable with respect to another variable, and in some cases we represent it as the change in the variable y with respect to the change in the variable x, also represented by dy dx, also represented by fx, that's with an apostrophe on top of it. And then we also could also be in the form df of x, or d dx of d dx of the function, right? Could also be df over dx, right? So it simply explains the rate of change of a variable with respect to another variable. So in general terms, we could connect the definition to the limits, right? So the limit as the change in x tends to 0 for f of x plus the change in x minus f of x all over the change in x. What does this imply? That means that f of x is changing with respect to x. That's why I have f of x plus change in x minus f of x, and this corresponds to the change in y, right? And then over the change in x, that gives us the differential, right? And another thing to note is, given a function f of x, the derivative is also known as the differential, right? Is also known as the differential coefficient, which is equivalent to the first derivative of the function. So let's go right into what this actually explains. So remember my video when I looked at limits, right? And I said the first step to evaluate a limit is by direct substitution of the terms. But if direct substitution leads to 0 over 0, then we either apply L'Hopital's rule, or we use a simplification or a factorization. So in the case of this now, if you substitute x as 0, please, in this definition, change in x is not equal to 0, because for a differential to exist, or for a derivative to exist, we are talking about the rate of change of the x and the y values, right? So if we should simplify this limit right now, we'll have, that will imply f of x plus 0, right? And then minus f of x, and then we are having over 0. That's f of x minus f of x over 0, which is leading us to 0 over 0. So that's an indeterminate form. And one thing we said about an indeterminate form is that, first of all, the function is undefined at that point. That's why I said the change in x is not equal to, right? Is not equal to 0, because if it's equal to 0, the function of a differential is undefined, right? But what happens? The limit, what it exists. So what we simply do is to just simplify the function for us to get what that differential, or what the differential of the function is. So then this takes us to the first principle, right? So to this formula I just wrote now, which says that the limit of change of x as x tends to 0 for f of x plus change in x minus f of x minus change in x, is what we use for the differentiating from first principle. So let's say we are given y equals to x squared, and we have to differentiate from first principle. What's the formula saying? F of x plus change in x. So that means anywhere we see x, we are replacing it with x plus change in x. So the derivative, which is f prime x, is equal to x plus change in x to the power 2 minus f of x, which is x squared, right? All over the change in x. So let's simplify. So an expansion of this, I hope you can see clearly. An expansion of this, we're going to be having x plus change in x into x plus change in x. If this multiplies this, we'll have x squared plus, if this multiplies this, that'll be x change in x plus, if this multiplies this, we have plus x change in x plus change in x all squared, right? So these two are like terms, so we could write it as x squared plus 2x change in x plus change in x all squared. So we can now simplify the numerator as x squared plus 2x change in x plus change in x all squared minus x squared. So we can now see that the x squared and the x squared will cancel, and then remember we have a denominator that bears change in x. So at the final point, we'll have 2x change in x plus change in x all squared over change in x. Remember there's a limit as the change in x tends to 0, right? So divide through by change in x, that will be 2x change in x over change in x plus change in x squared over change in x, right? So that's going to leave us with 2x plus change in x, because one change in x will cancel another, right? And we left with just one change in x. And since it's the limit as change in x approaches 0, what happens? Anywhere we see change in x, we replace it with 0. That'll be 2x plus 0, which is what? 2x. So that's, we just simplified it so that anywhere we now have change in x, we substitute 0 to actually get the limit, which gives us the differential. So let me take another. If maybe it's y equal to, let me say y equal to 1 over x squared. The same principle, the limit as change in x tends to 0, right? All we now do is 1 over x plus change in x all squared minus the original function 1 over x squared all over change in x, right? So we could easily simplify this. I've already squared 1 x plus change in x before, so x plus change in x all squared is x squared plus 2x change in x plus change in x all squared, right? Minus 1 over x squared. Don't forget we have a denominator underneath. So we take the LCM as x squared into x squared plus 2x change in x plus change in x to the power 2, right? So if this whole denominator, this LCM divides this, we're going to be left with, that is, this goes into this, we'll be left with x squared, and then minus this going into this, will be left with minus x squared plus 2x change in x plus change in x all squared. I hope you grab. Then from there we can simplify, right, as x squared minus plus is giving us minus, so we have minus 2x change in x, right, minus change in x all squared. So you can see that this can cancel this, right? And then all over x squared into x squared plus 2x change in x plus change in x all squared. Remember, we're looking at the limit as change in x tends to 0, right? And then from there we then divide by change in x, right? So we could then, all we could then simply do is to multiply the expression by 1 over change in x, right? So that would be negative 2x change in x minus change in x squared over x squared into x squared plus 2x change in x plus change in x all squared, right, times 1 over change in x, because that's division. So change in x into change in x will leave us with negative 2x, right? And then change in x squared, change in x all squared divided by change in x is going to leave us with 1 change in x, right? So finally we then have, sorry for that, so then we could then simplify the expression as negative 2x minus change in x over x squared into x squared plus 2x change in x plus change in x all squared, right? And then We could go on to simplify. That's negative 2x, negative change in x over x squared times x squared. Using law of indices is going to give us x4, right? That's x4 plus 2x times x squared is going to give us 2x cubed change in x plus x squared times change in x squared all squared is going to give us x squared change in x all squared, right? So remember, we are tackling the limit as x tends to changing x tends to 0. So at this point, I don't think we're going to be having an indeterminate of 0 over 0. So we just simply substitute 0 anywhere we have change in x. So that's negative 2x negative 0. And then we have x4 underneath. And then we have plus 2x cubed. And then we're going to end up with 0 plus. We're still having another change in x right here. So we're going to have 0. So that's simply negative 2x over x4, right? So x into itself 1, x into x4, that we're going to be left with x cubed, right? So our final answer is going to be, that's will be equal to negative 2 over x cubed. That's what it is. So that's what we simply do. You see, whatever function you're given, you add that change in x to it, and then you subtract the original function. So that leads us to the first type of because I don't think, according to what we have in Maths 103 to do, I don't think we'll actually be asked to prove by first principle or stuff like that, but we may just test you on some theories that are involved, right? So let's look at this right now. If you're given a function in the form y equal to x raised to power n, what will be the derivative? The y over the x is equal to n x raised to power n minus 1. And this is not a formula that was gotten from the air, right? All formulas we use to get the differentials are simply gotten from the first principle formula, which says, I've stated it before, as x tends to change in x tends to 0 of f of x plus changing x minus f of x over changing x, right? So in the case of x raised to power n, let's consider a function x raised to power n, right? So if you're given x raised to power n, how do we tackle it in this case? So if we are doing that, that means the limit as change in x tends to 0 now, since we have x plus change in x in the bracket, to now be x plus change in x raised to the power n minus f of x, which is x raised to the power n, right, over change in x. That gives us the differential. Now let's continue simplifying so that you see y is nx n minus 1. So this is x plus change in x to the power n, right? And then using the binomial theorem, we did that in Maths 101. We'll first of all say n combination 0, and then x raised to the power n negative 0, and then change in x to 0, and then n combination 1, x to the power n negative 1, then changing x to the power 1, and then it continues n combination 2, x to the power n minus 2, changing x squared, and then it continues. But why do we have the right to stop here? Remember that if after simplifying and then you have change in x at the end point, what happens? Anywhere you see change in x, you substitute 0. So what we can notice here is that on simplification of this, n combination 0 is always 1, right? When you do the combination simplification, and then have x raised to power n minus 0, which is leaving us with x raised to power n, and then any value except 0 raised to 0 is 1, right? So that's xn times 1, that's xn plus n combination 1 is going to give us n, right? Because we are going to have n factorial over n minus 1 factorial 1 factorial, right, which is equal to n into n minus 1 factorial over n minus 1 factorial 1 factorial. This cancels this, you're left with n. Let me grab, and then we have n x n minus 1. Do you see it? And then we have change in x, and then you see that the power of the change in x now becomes squared. So if we should come underneath and divide by change in x, remember at the end of the day we are going to subtract from the original function, which is x raised to power n. So this x raised to power n here will cancel, but you see that the change in x power is increasing. Do you understand? So if this change in x divides this change in x, we'll be left with nx raised by n minus 1. But if it divides change in x if change in x all squared divides change in x, we are going to be left with change in x. If change in x everything cubed divides change in x, we'll be left with change in x squared, right? And at the end of the day, when you are simplifying, you know that anywhere you see change in x, you substitute 0. So all others will now receive 0 as outputs. Do you understand? All others will then receive 0 as outputs, right? All others will receive 0 as outputs because change in x squared, change in x will leave us with what? Change in x. And when you are now evaluating the limit, anywhere you are seeing this, you're going to put 0, right? And then even though it has change in x to the power cubed, and then change in x, you're going to be left with change in x squared, right? Which is still giving you 0. So we are stopping at this point, which is nx n minus 1 change in x over change in x, where change in x is eliminated. Do you understand? So the differential of a function in the form nx to the power n minus 1 is literally n, in the form x raised by n is literally nx raised by n minus 1. That's the differential. And even though you are giving y equals to ax to the power n, it's still the same thing. You're just going to do a times n x raised by n minus 1, which is an x n minus 1, right? So example, if you are giving x to the power 10, right, what's that going to be? You bring down the n, right? That's 10x to the power 10 minus 1, which is going to give us 10x to the power 9, right? If I'm giving 3x to the power 4, I bring down the 4, it becomes what? 3 times 4, then x raised to the power 4 minus 1. That's the n minus 1 I'm talking about. That's 3 times 4, 12, and that's then x to the power 3. That's the differential. That's the rate at which y is changing with respect to the x values, right? So that's what this is all about. So even in the case of trigonometry, which would look into deeply in part 2. For example, if you're asked to differentiate sin x from first principle, right? What do we do? Remember the rule, f of x plus change in x minus what? F of x over, that's the principle. So all we then do here is anywhere we are seeing x, we're going to replace it with x plus change in x, right? So that becomes sin x plus change in x negative the original function, which is sin x, right? I know that sine is a special function, and for functions in the form sin a plus b, what's sine rule? Sin x plus change in x is going to be equal to sin x cos change in x plus sin change in x. We did this in math 101 in trig. Sin change in x cos x minus sin x, regrab, and then over, this is using sine formula, right? So continuing, you can see that this sin x can factorize this sin x. That will be sin x into, remember we are looking at the limit as change in x tends to 0, right? So sin x into cos change in x minus 1 plus sin change in x cos x over this, right? So at the end point, what do we then have? We can now split it as sin x into cos change in x minus 1 all over change in x plus sin change in x cos x over change in x. And then we could use some rules we used in limits to actually simplify this. Remember we said, if you watched my videos on limits part 2, where I said that limit as x tends to 0 for cos x over x 1 minus cos x over x is 0, right? While the limit as x tends to 0 for sin x over x is 1, right? So that's the same thing we apply here. So looking at this part, and this is cos, looking at this portion, this is similar to this, right? It's in conjecture with this. So we can then say that the limit is sin x into 0, right, plus this is in conjecture with this, right? with this lim x to 0 sine x over x. So that's 1 times, there's a cos x left here. I hope you can see clearly. Sorry if you can't see clearly. So we are now left with cos x plus 1 times, that's what? Cos x. That explains why the differential of sine is cos. And then you could also use this, apply this to other trigonometric ratios, and then you're able to evaluate the answer. So let's move on with this stuff right now. Another important thing I want you to jot down is that the differential, that's the next thing to know, that the differential of a constant is 0, right? Differential of the constant. So let's consider a function in form f of x equal to k. You watched my video on introduction to functions. We plotted the graph of f of x equal to k. We considered the y-x coordinate, the xy coordinate, and then we're like its streams, positive infinity, negative infinity, could even be on the negative side, right? So why is it 0? Remember, derivative is talking about the change in y with respect to x. So there is no change in the value of y. If there is no change in the value of y and the values of x are changing, 0 over anything is what? 0 over any number, let's say a, is what? 0, except 0, right? So as here, it's still receiving the same output. So there's no change in the value of y, irrespective of the fact that the values of x are changing. Do you get it? So that's basically why the differential of the constant is 0. So let's take this question now. If you are given y equals to 3x to the power 4 plus 6x squared plus 9x plus 11, and you're asked to find the y dx in your exam, what do? Follow the laws. You use derivative by sum. You can differentiate them individually and then combine, right? So having that, we bring down the 4, it becomes 3 times 4, x to the power 4 minus 1. We bring down the 2, it becomes 6 times 2, x raised to the power 2 minus 1. In this case, we have 1, right? And then we bring down the 1, that will be 9 times 1, x to the power 1 minus 1, plus differential of a constant is what? 0. Right, so 3 times 4 is 12, that's x cubed, plus 6 times 2, that's 12, x 2 minus 1 is x, right? And that's plus 9 times 1, 9, x raised to the power 1 minus 1, 1 minus 1 is 0, right? So, and any number except 0 raised to 0 is 1. That's 9 into 1 plus 0. So that's 12x cubed plus 12x plus 9. That's the differential dy dx, or you could say f prime of x. That's the first derivative of the f of x, right? Take note of stuff like that. So it's quite simple. We could actually be asked, because I think I saw a question, I don't think it's actually necessary. You could be asked, what's the differentiate this with first principle? What do? Follow the same principle. You say 3 into x plus change in x. You can do this yourself, right? Plus 2 into x plus change in x. Whether it's it's not a must that the function given would be just containing one element. They could give you y equals to 3x squared plus 2x, and then you have to differentiate from first principle, right? So you do it anyway. You're seeing x in that function, you're replacing it with x plus change in x, right? So at the end of the day, you subtract from the original function, which is 3x squared plus what? 2x, right? And then at the end of the day, you divide by what? Change in x as a rule. And then at the end of the day, if you follow the procedure I just explained, the 2 comes down, right? It becomes 3 times 2, x raised to the power 2 minus 1, plus there is an invisible 1 here, the 1 comes down. That's 2 times 1, x raised to the power 1 minus 1, and that's leaving us with 3 times 2, that's 6, then x raised to the power 2 minus 1, that's x, and then plus 2 times 1, 2, x raised to the power 0, 1. So we have 6x plus 2. At the end of the first principle process, you still be arriving at the same answer. The way grab, that's essentially what this is all about. And then I want to go over to the other rules that exist that could help you solve questions that are involved in this trig of stuff. But before I go into that, in the material for Mark 103, there's something I saw over there, and it says the singularity of a what? function, singularity. And I want you to jot this down because the grammar that may have been used in material may seem a bit confusing. So what this is actually trying to say is the value of x for which that differential does not exist, right? The value of x for which the differential does not exist. So let's see this now. For example, if you are given x raised to power minus 1 over 2, what happens here? If we differentiate this, irrespective of whether it's negative, I hope we know that x raised power minus a is the same thing as 1 over x raised power a. So x raised power negative half is same as 1 over x to the power half, right? So putting it in this form, we then bring that in negative half, and then we have it as negative 1 over 2 x negative half minus 1. You follow the same principle, whether it's a fraction or not. And that is negative half minus 1. You should now also simplify fractions. That's 2. 2 divided 2, that's 1, right? And then we have negative 1. 2 over 1, that's 2 times minus 1, that's minus 2 when we multiply, and that's leaving us with minus 3 over 2. So at the end of the day, you are seeing that having half x raised to the power minus 3 over 2, which is same as minus 1 over 2 times 1 over x raised to the power 3 over 2. Still the same thing, right? So we are now removing the negative index by finding its reciprocal, right? So that's negative half x, negative half 1 over 2x to the power 3 over 2. So if you're asked to find the value for which it's singular, right, this is the differential, right? Because remember, we are looking at the limit as change in x tends to what? 0. So if the limit of that's you've differentiated it, and then you are now looking out for the values for which the differential does not exist, right? That's simply what it is. So if you equate the denominator to 0, 0 divides 2 leaves us 0, and x is likely what? 0, right? Because 0 is only 0 raised to something that will leave you with 0, isn't it? So that is what it is. That's what singularity is all about. The values of x for which the differential does not exist for that particular function. The values of x for which the slope does not exist, or maybe the left hand. Remember, we said that for a limit to exist, what did we say? If you watched my video, I said that as x tends towards c plus should be equal to what? The limit of x tends to c from the right. So that is trying to say that the slope from the left should be equal to the slope from the right, and then the denominator, if at the end of the day is a rational, should not be what? Should not be 0. If it's 0, then we have a singular, right? So the next thing we are going to go to now is the product rule of differentiation. Product rule, not difficult. It says that for two functions u, v, the differential given a function f of x, sorry for this, equal to uv, right? The first derivative of f of x is equal to v du dx plus u dv dx. This is still derived from first principle. It's still the same thing, but I would not want to waste the time by explaining that. But I'll just give you a hint. If you should differentiate this, all you simply do is u plus changing u into v plus changing v, right? And then at the end you have uv plus v changing u plus u changing v plus changing u changing v, and then at the end of the day you divide by what? Changing x, right? Do we get? And then remember, we're going to subtract from the original function, which is uv, so this cancels, right? And then you're left with v changing u over changing x plus u changing v over changing x plus, remember this is the limit as x is approaching 0, and then you're left with changing u changing v over changing x, and this is going to cause a problem. Changing u is also tending towards 0 based on this what we have right now. So change in u, the limit of change in u, change in v over change in x is going to leave us with 0 into change in v over change in x, because change in u is tending to 0. So in this case, where we have differentiating each of them to be v du dx, right? Because change in u over change in x is du dx plus u dv dx. That's where it came from, right? So let's say we're given a function f of x equal to 3 plus x into 4 plus x squared. You're given this. So you can take it anyone as your, you take this, maybe take this as your v and then apply v du plus u dv. So v in this case is 4 plus x squared, right? Then du, differential of 3 is 0, right? And then differential of x is 1, because x to the power 1, the 1 comes down, it becomes 1x, 1 minus 1, that's x to 0, that's 1, right? Plus u, which is 3 plus x, into the derivative of v. If we differentiate 4 plus x squared, that's going to leave us with differential of 4 is 0, I've said it. Differential of x is 1, differential of x squared is 2x, right? Into what? 2x plus 1. So that's simply the answer. So our final answer is 4 plus x squared plus 3 plus x into 2x plus 1. And I think this could be simplified. If we expand this, it's giving us 6x plus this and this becomes 2x squared plus 1 and 3, that becomes 3. 1 and x, that's x. And then we have 2x squared plus 6x and x is 7x, and then plus 3. And then we add it to 4 plus x squared, right? And that leaves us with plus 2x squared plus 7x plus 3. Collecting like terms, we have 3x squared, x and 7x gives us 8x, and then 4 plus 3 is 7, right? So that's the final answer. That's the derivative. If it's not simplifiable, or if it takes some time to get the final answer, then you just leave it in that form, right? Do we get? So let's take this question again. Not difficult. We are given this, and then maybe x to the power 4 negative 3x squared plus 7x. We are given this, not much stress, just choose your u and v, right? Choose your u, choose your v, and you use what? b du plus u dv. So u is going to give us x squared negative 3x plus 5, and then the v, if you differentiate this, is going to give us 4x raised to the power 4 minus 1, which is 3, minus 6x plus 7, right? Into 4x cubed minus 6x plus 7, then plus u, which is x. Okay, we did v du, right? Okay, what we did now is u dv. Okay, so let's get v du. V du is going to be x4 minus 3x squared plus 7x dv du. We are doing v du right now, and that's going to be, if we differentiate x squared negative 3x plus 5, we have 2x negative 3. So that's simply the answer. I hope you know what I mean by the answer. My final answer can be written as x4 minus 3x squared plus 7x into 2x minus 3 plus x squared minus 3x plus 5 into 4x cubed negative 6x plus 7. You could leave it that way, right? Because expanding it may take some time. So that's it about that rule, right? So it's very important to take note of it. V du plus u dv. I don't think you should have the capacity or you would allow yourself to forget that, right? So the next thing we'll then move to is quotient rule. Quotient rule is still derived the same way. Or what? U over v. The function is of the form u over v. The differential of the function is simply v du negative u dv over v squared. So please pay heavy attention to this, because v du minus u dv is not the same as u dv minus v du. In the product rule, you could not easily make mistakes because what we are having is v du plus u dv. So addition is commutative. So no matter where you're starting from, you have problem. But if you mix it up for the quotient rule, you won't get it. So v du minus u dv over v squared, where the u is the numerator of the rational function and v is the denominator of the rational function. So let's say we are given this question now. We are given y equal to 1 negative x over 1 plus x squared and you asked to differentiate it. What do? It's not difficult at all. Take this as your u, take this as your v, and then you now write down the formula v du minus u dv over what? V squared, right? So the v is 1 plus x squared, right? Now we're doing v du. If you differentiate one negative x, differential of 1 is what? 0. Differential of negative x is minus 1 because the 1 on x will come down and then raised to power 1 minus 1, which is 0. That's x raised to power 0, which is 1. Then 1 times the negative, that's minus 1. So that's 1 plus x squared into minus 1 minus, then if we then do, let me make it clearer. Remember, this is the function we are given, 1 plus 1 minus x over 1 plus x squared. So we then have 1 plus x squared into minus 1 minus, now u is 1 minus x into dv. Remember, this is u, this is v. If we differentiate 1, it's 0. Differential of x squared, that will be 2x, right? So we then have it as negative into 1 plus x squared minus 2x into 1 negative x. This one can be simplified. And then remember, don't forget the denominator. That's 1 plus x squared to the power 2. Because we are squaring v, right, at the end point. So with that, we simplify. Negative 1 minus times plus is negative, that's x squared minus 2x. Negative 2x times this. My negative is positive, right? And that's why we have positive 2x squared. And then we can then simplify. Negative x squared plus 2x is x squared, right? Negative x squared plus 2x squared is x squared. And then we have negative 2x and we have negative 1. And then everything into 1 plus x squared to the power 2. So that's the differential, the first derivative, the differential coefficient of that function. Do we grab? Please, I hope you're grabbing. I'm sure you saw my number on the screen, right? If you have any questions, please do well to notify me and I'll be very happy to respond to your question based on all that I've been saying. Right, so that's the quotient rule. I can take another question. Let me see one I could take right now, so that and I could even pause the video to attempt the question and I'm about to write right now. So if we are given a function y equals to 2x plus 1 over x negative 1, and we actually differentiate it. This is u, this is v. Pause the video and try it, please. So divide the x by what? V du minus u dv over v squared, right? So what are v? X minus 1, that's x minus 1 into du. If you differentiate 2x plus 1, it's going to give us 2, right? I hope you agree. Yeah, because differential of 2x is 2, and then differential of positive 1 is 0. Then minus u, right? Minus u, which is 2x plus 1, dv. Differential of x minus 1 is 1, right? Because differential of x is 1, differential of negative 1 is 0, right? So what then happens into 1, right? So we could easily simplify as 2x negative 2, because 2 into x, 2x. 2 into negative 1, negative 2, negative 2x. Negative times positive is negative 1. Then 2x could cancel, right? And then we're going to be left with minus 3, right? I hope we're grabbing. Then don't forget the denominator. At the end of the day, we'll square v, right? So our final answer for f, which is still dy dx, which is d of f of x, right, is equal to minus 3 all over the denominator, which was x minus 1, everything squared. That's the answer to that question. I hope we are grabbing. So that's what quotient rule is all about. If you ask the question, you could easily get it. It's not difficult. But then the next thing we'll go to now is the chain rule. Chain rule, very important. And the chain rule says that given a function f of x that is made up of two functions in one or two or more functions in one, the differential dy dx is equal to du over dx times dy over du. And we're not lying, because this du cancels. It's still the same thing, but we're just defining it that way so that we could get something out of what we have. So let me give you, this is times, so it'll be cool. This is times. So let's see how we could apply that to solve questions. So let's say you're given this in an exam. If the lecturer gives you 2x plus 1 to the power of 12 and asks you to find dy dx. Number one, it would be highly impossible for you to start expanding this, right, to get the dy dx, right? So they actually want you to use chain rule. So why is this chain rule? There's a function inside, which is what? 2x plus 1. That's the first function. And then the second function is raising 2x plus 1 to the power of 12. Those are two functions, right? So what do we simply do? What you say is let u be equal to 2x plus 1. You could say let anything, but just follow the principle, right? So you can say let u be equal to 2x plus 1. So you then get du with respect to x, right? So du dx is what? It's going to give us 2, right? It's going to give us 2. So don't make the mistake of bringing down 12, and then you now say 12 into 2x plus 1 raised to the power 12 minus 1, which is 12 into 2x plus 1 raised to the power 11. That would be wrong, bro. That would be wrong, right? So what do? Du dx is giving you 2, right? So you could now write, since you said let u be equal to 2x plus 1, you can now rewrite the function as y equals what? U to the power of 12. Are you getting it? So then you can now write what? Dy over what? Du. So dy over du now is bringing down 12, and that's 12u raised to the power 12 minus what? 1. Using the same principle where we said if we have x raised to the power n, the differential is x raised to the power n minus 1. I hope you are getting it. So it's now 12u raised to the power 11. So we'll now multiply the du over dx, du dx by dy dx to get, because so that this du will now cancel this and you'll be left with dy dx. So what you then have is 2 times 12u11, that's 24u11. So you now say recall u is equal to 2x plus 1. So what's going to be your final answer? Sorry? What's going to be your final answer? It will be 24 into 2x plus 1 to the power of 11. That's it. Do you understand? That's what this is all about. So let me see another one now. I can see another question that is saying 1 plus x to the power half. Same thing. You are seeing a function 1 plus x and there's another function raising it. So what do? Let u be equal to 1 plus x. Differentiate it. That will be dy du. Differential of 1 plus x is 1, right? Then, sorry, du dx. This is du dx. Du dx, you are differentiating u with respect to what? X. So that's 1, right? And then you now, since y is equal to 1 plus x, so what will you have? Y equal to u to the power half, right? So if you differentiate y with respect to u, it's going to give us, the half comes down, right? That's half u to the power of half minus 1. and that half u to the power half minus 1 is going to give us minus half, right? So this half u minus half will now multiply by 1, right? Do you get? We'll now multiply by 1, and then we'll be left with half u to the power half. Then we'll now recall. Are you getting it? So we now recall that u is 1 plus x, and that's 1 plus 2 into 1 plus x to the power negative half. And remember the negative law index, you could bring it down, and it becomes 1 over 2 into 1 plus x raised to power half. That is without the negative index. I hope you're not confused. I hope you're not confused. Because we have a negative power. I said that if you have a value, let's say x, raising to negative something, let's say a, the same thing as 1 over x raised by a. So now you have 1 plus x raised by minus half, the same as 1 over 1 plus x to the power of half. That's without the negative. You get? So that's the final answer to the question. So ensure you take note of this, very important. If you use the normal way without using chain rule and there are two functions involved, you will fail it. Do you understand? So I hope you get it. So let me take more questions so that it would be clearer to what we are saying here. So I have another. Okay, let's see. We're given this. If you are given this in exam, remember these are two products, but for this kind of question now, I just be very, very careful. If not, I'm gonna mess up, because you are seeing that there are two functions, right? 2 plus x and 3 negative x raised to half, but they are actually 3, right? Because there's another function that is raising 3 negative x to the power half. So this is going to be very, you still follow the same principle. You say let this be u, let this be v, and then you're using product rule this time, right? And that says v du plus u dv, right? So with that, what do we then have? It becomes 3 negative x to the power half du, right? Du in this case is 1. Differential of 2 is 0 because it's a constant. And then plus u, which is 2 plus x dv. If you differentiate, are you seeing where the problem now comes? So we now have to differentiate dv. We now have to not dv. We now have to differentiate v to get dv. That means we have to differentiate 3 negative x to the power half. This is not square root. 3 negative x, and what do? We have to use chain rule to differentiate it. Do you get? So that will now be, you now say let u be what? 3 minus x. The u over the x is what? Minus 1. Do you understand? I hope you understand why it's minus 1. Because this is minus x, right? So the 1 in the x comes down, and then it's minus 1 x raised by 1 minus 1. And x raised by 0 is 1, so we have minus 1. Then you will now say y is equal to what? U raised to power half. Abi? So that will be half u raised to power what? Minus half, because that's half u raised to power half minus 1, which is minus half. And that's the same thing as 1 over 2 into u raised to power half, using what I just explained now. So this value now, your final dv dx will now be times the minus 1 you got. I hope you are flowing. That is minus 1 you got. So what will now be your answer? 3 minus x raised to power half. This 1 is not having effect. It's just times 1 plus 2 plus x multiplied by the dv, which is that function, times what? Minus 1 over 2 raised to power u half. And what is u? 3 minus x raised to power what? Half. Are you seeing the gist? So at the end of the day, the first derivative of the function is 3 minus x. Minus times plus is minus, right? So that's minus 2 plus x all over 2 into 3 minus x to the power half. Do you understand? These are also the kind of things you are likely to face, right? These are also the kind of things you're likely to face So there's nothing else. The only other thing we have to look at is trigonometric functions, which is very important. We have to look at logarithms, right? Logarithm functions and stuff like that. And then that's literally all. But to give you an introduction to what we'll do, because in part 2 we'll be looking at um, differentials of trigonometric functions. We're going to look at differentials of logarithmic functions, right? Like if they're asking what's the differential of ln x and what's the differential of ln x plus ln x of something, or ln x of a function and stuff like that. We're going to look at it, and then other important things you need to know about differentiation. This will have a part 2, some may go into part 3 and all of that. So there's one function I want to tell you about before this video will come to an end, and it's the function e raised to power x. If you check your material, says that the differential of e to x is still e to x, right? It's still e to x. We grab e to x. But in exam, they are not likely to ask you what's the differential of x. What you may see is they could give you e to 3x plus 5. Are you listening? So how do you solve something like this? What you will say is, let u be equal to what? 3x plus 5. You now find the y du. Sorry, du dx. You differentiate 3x plus 5. What are you going to get? 3, isn't it? I hope you know why it's 3. I've been watching this video since. So. Right? So that's what you have. And then you now say y is equal to what? E raised to power u. Because you said let u be what? 3x plus 5. And then if you now find the y du, differential of e raised to power u will still give you what? E raised to power u. Do you get? So our final answer will be the y du times du dx. That will be 3e Do you understand? And at the end of the day, you will now say that the y over dx is what? 3eu, and then you now recall that u is what? 3x plus 5. Your final answer will now be what? 3e to the power of what? 3x plus 5. So if you are giving something like e, they can say 3x squared plus 9x plus 4. You differentiate this, right? And if you differentiate this, you get what? 6x plus 9. That is du dx. But the y du now be e raised to power u, which is this. So it will be 6x plus 9e raised to power what? 3x squared plus 9x plus 4. These I'm just trying to look at, tell you, open your mind to how these chain rules, how you can apply chain rule to different. This also applies to trig. We're also going to be looking at it in trig functions. So very important too, right? Very, very important to take note of. I can't actually see any other. I want to give you some questions to attempt. Some questions I have here based on what we've done. Follow the principles. We looked at the sum rule, we looked at product rule, we looked at quotient rule, we looked at chain rule. Very important. Chain rule. We looked at chain rule. So you don't joke with that. So this one I want you to attempt it, and then I'll still solve it. Attempt, pause the video and attempt. We have 3x squared plus 5 raised to power 4. And they ask you what's the differential? What's the differential coefficient? Or they say differentiate with respect to x. Have you paused? So the answer to this is for you to say let u be equal to what? 3x squared plus 5. And then the u over the x. We differentiate 3x squared. The 2 will come down. It becomes what? 3 times 2 raised by x raised by 2 minus 1. Differential of a constant is what? 0. So we have 6x, right? So that would be du over dx. So you now see that y is equal to what? U raised to power what? 4, because he said let u be what? 3x squared plus 5. So the y over du now will be what? The 4 comes down and it becomes 4u raised to power 4 minus 1, which is 4u to the power 3. So at the end of the day, you multiply du over dx by the y du. Do you understand? That will be 6x times 4u cubed. So this 6 and 4 can marry, and then we have 24x and then u cubed. And then you now recall that u is what? 3x squared plus 5. So what will be your answer? Your final answer? 24x into what? 3x squared plus 5 to the power of what? 3. So that's simply what it is, right? That's simply what it is. Please do well to subscribe. If you have not subscribed to my channel, please do well subscribe so that when more videos like this are coming, you would get it, right? Also like this video, share these videos to other students, other people that need it, and then I'll be very happy with that. And then also put in your comments, questions you have, any reviews you have to put in, any contributions, please do well to put it in the comment section. And then another question I would give you this video now is let me see, I want you to derive the differential of tan x, right? Remember that tan x, if you are reading your maths 101, you know that tan x is what? Sin x over cos x. So you can use quotient rule to derive the so you can attempt it. I won't solve it in this video. In our next video, we are going to look in detail into trigonometric differentials, and then everything is going to be alright. Then my last question before this video comes to an end is this: if you are given this s square minus 2s plus 1 e raised to power 3s plus 7, this is the question. This involves two functions. This is product rule you will use. Do you understand? So what does product rule say? V du, which is e raised to power 3s plus 7. If you differentiate du now, if you differentiate s squared minus 2s plus 1, what will you get? You get what? 2x minus 2 plus u, which is what? S squared minus 2x plus 1 dv. Now what's the differential of this v now? I've explained how to get it by chain rule, abi? So if you differentiate 3x plus 7, you get what? 3. And your final answer can be written as 3e raised to power what? 3x plus 7. So this now you multiply by what? 3e raised to power 3x plus 7, which is the differential of v. So your final answer of the first derivative will be 2x negative 2 into e raised to power 3x plus 7 plus 3e 3x plus 7 into x squared minus 2x plus 1. You can write it any order. It's a product, so product is also commutative. So that's it. That's the answer to the question. Thank you so much for watching this video to this point, and I hope you gained a lot from this. Do well to subscribe. I'm reminding you again, subscribe, like, and share. So do well to comment on this video. Thank you so much and have a nice day. Yeah.